In any automobile industries, painting plays very important role, first on product appeal to customer, and second on the protection of steel substrates from corrosion. Hence painting process of automobile is of vital importance to attain the aesthetic and durability of the vehicle in the service. In general, automobile painting consists of multiple coatings which are shown in the below table 1 and picture 1. Conventional painting process. In any automobile paint shop, car body passes through the pretreatment and electro-deposition line which contains series of spray and dip tanks to treat the steel car bodies. In pretreatment, steel substrate is treated to remove the oil and finally get coated with tricationic zinc phosphate layer. In electro-deposition, most of the OEMs are using latest generation cathodic E-coat paint for better throw power and smooth finish along with higher transfer efficiency. After electro-coat baking, the sheet metal joints are sealed with PVC-based sealer to prevent water leak, sound dampening and corrosion, followed by the application of underbody coating in the underbody. Most of the automobile OEMs in world are using medium solid solvent-based paint technology for top-coat painting. In top-coat process, primer coating is sprayed and baked in oven. After baking, car body is prepared for final painting with base coat and clear coat wet on wet before baking once again. Hence the conventional painting system is called 2-wet process. Also known as 3 coats 2 bake painting system, 3C2B. Why 3-wet painting? In order to reduce the emission of both VOC and carbon dioxide which is generated during the painting process and to become cost competitiveness in the global automobile field with cutting-edge technology, Many auto industry has adapted to the new 3-wet high solid based paint technology in conjunction with global paint suppliers. This new coating system make it possible to apply primer coating, base coating, and clear coating continuously wet on wet before baking the car body in the oven. With this change, there is no requirement of separate primer scuff booth, primer booth, and primer oven. Hence the new process is named as 3-wet process, 3B1C. The picture 4 shows simple layout of 3-wet painting process in sequence. Above modified process layout can be simplified based on coating layers as shown below in picture 5. Technical challenges faced. Appearance. Equal or better quality than conventional system. New materials. New process. Substrate sensitivity, E-coat roughness and metal cleanliness. Sealer PVC compatibility. Cut-in overspray compatibility. Material performance. Short-term, chipping, adhesion. Long-term weathering. Process sensitivity. Migration of additives and low molecular weight molecules. Paint appearance quality is a term that refers to the smoothness and gloss of the paint coating, and this is measured by the wave scan system manufactured by VOC. The system measures the degree of surface unevenness by wavelength, long wave LW and short wave SW. Lower wave scan values indicate smaller unevenness and, therefore, higher appearance quality. Smoothness is related to LW unevenness and that gloss is related to SW unevenness. Therefore, reducing this unevenness is regarded as the key for improving appearance quality. Mechanism of paint film unevenness formation. Phase 1. Unevenness forms shortly after spraying the primer to the ED-coated body surface. The unevenness of the ED-coated surface, RA value, is an important factor to affect the unevenness of the primer surface film. Phase 2. The degree of unevenness is changed by the flow of primer paint film created by surface tension, a process called leveling. The degree of leveling increases as the viscosity of flowing primer decreases. Phase 3. In this phase, heat applied during preheating, water-borne primer, or baking results thermal fusion, which promotes the leveling process, further reducing the unevenness. The unevenness that forms in the phase 1 to 3 is mainly long wave, LW, and affects smoothness. Phase 4 and Phase 5. In these phases the final baking is applied after the application of clear coat. In Phase 4 and Phase 5 the final baking is applied after the application of clear coat. This promotes reactions, contraction, that reduces or stops the flow of the paint film. After the film flows stopped, the unevenness of the substrate and underlayers is transferred to the top surface. The fine unevenness that controls the quality of gloss is formed by volume contraction during later phase than the unevenness that affects smoothness, toward the end of the baking process. The unevenness that forms in Phase 4 and 5 is mainly short wave, SW, and affects gloss. The fundamental paint film formation mechanism for 3-wet paint system is presumed to be the same as for 3C2B paint system. But only difference, baking is not applied after primer application followed by base and clear coat wet on wet. To launch and implement the 3-wet process, a collaborative approach has been initiated along with paint and facility suppliers. Detailed and exhaustive development work has been carried out for facilities and paint materials developments. Based on the film forming mechanism, various DOE have been carried out to improve the paint appearance quality and coating performance. The outcome of these research works to incorporate in new 3-wet paint material developments are summarized as below. Step 1. Selecting high performance, lower RA value, of E-coat material. Step 2. Introduction of interface control polymer, newly developed primer. Step 3. Base resins with low TG and molecular weight were selected to ensure sufficient leveling performance. These base resins were adopted in the primer and base coats. Step 4. To reduce volume contraction during baking, the melamine content of the paint is reduced and modified by adding blocked isocyanate, B and CO, so as to have no loss of baked film performance. This measures was applied to the primer. Paint material development for 3 wet painting system. 3 wet paints are very sensitive for merging between primer and base coats, since all 3 layers such as primer, base and clear coats are applied wet on wet. To prevent this, developed a new resin called an interface control polymer, and this is added to the primer paint. When the primer is applied, the interface control polymer creates a barrier layer on the paint surface. Though uniformly dispersed throughout the primer when it is applied, the larger molecules of the interface control resin are soon drawn to the surface of the thin layer of paint by surface tension, where they form a highly viscous barrier layer at the interface between the primer and base coat. This technology prevents merging, color degradation, and ensures the finished quality is as good as or better than conventional coating methods. As already mentioned, the existing conventional primer, base and clear coats are not suitable for 3 wet processes due to mixing of both primer and base coat layers, as shown in the picture 6. Hence paint material supplier developed the new high solid primer, base and clear coat paint materials by upgrading the resin and backbone chemistry by introduction of boundary control resins in primer to avoid mixing with base coat layer as shown in picture 7. Paint appearance. Substrate smoothness, E-coat roughness RA value, has significant factor for overall paint appearance. The lower the surface roughness, the better will be the finish. Comparison of appearance quality of developed 3 wet paint system, current 3 wet paint system and 3C2B paint system. Figure 8. Showing the wave scan measurement results at various parts on the body surface. The developed 3 wet paint system has better LW and SW value than the current 3 wet paint system and almost same or better than 3C2B paint system. Coating material performance. Short term, stone chipping, adhesion. Long term weathering. Process sensitivity. All the above challenges were resolved by detailed validation and trials along with global paint suppliers before implementation. The few examples are shown below. Stone chip resistance measured by the SAEJ 400 technique and results are comparable and better than conventional painting system. Photo-oxidation, accelerated weathering. 3 wet materials are performing better than the current. Benefits of 3 wet painting system. Lean processing. Footprint reduction by 15 to 20%. Not only able to launch in the greenfield projects but also carries the brownfield conversion capability. Elimination of primer booth, scuff and oven, thereby reduction of the plant investment. Reduction in dock-to-dock, overall paint process time by 33%. Economics, capital investment reduction by from 15 to 25%. Savings in variable, energy by 30-35%, fuel by 20-25% and labor by 10-15%. Paint consumption reduction by 30-40%. Environment, carbon dioxide, emission reduction by 10-15, volatile organic compound emission reduction by 25%. With this new 3 wet technology, considerable improvement has been achieved in environmental emission apart from significant cost reduction through reduction of the paint consumption, power, fuel, and manpower resource optimization. Also, this technology is very much suitable for any greenfield project since millions of dollars can be saved in initial investment phase itself due to the reduction in shop floor footprint. However, the 3 wet technology will take next 3-5 years of time to gain popularity in the automobile painting process for 100% adoption by all automobile OEMs.